In this video, I'm going to be working through a few examples of free fall, including some things that are dropped from a certain height and one example of something that's being thrown upwards from the ground, and finding a few different things. So in this first problem, we have the Wizard of Oz. We have a house dropped on the Wicked Witch of the East. And so we had the house picked up by the tornado. We're going to assume that the house falls from rest. So the initial velocity of the house is going to be 0. So if the house fell from rest from a height of 3,000 meters, we want to find the velocity that it had when it hit the Wicked Witch of the East. We're going to be ignoring air resistance in this problem, so that's probably not the best approximation to make, but with this we're going to assume that if there's no air resistance, what velocity did it have when it reached the ground, and how much time did it take to reach the ground. So this house was starting at a height of 3,000 meters. The initial velocity of the house we're going to assume was 0 meters per second. Because it's in free fall, the acceleration of this house was negative 9.8 meters per second squared. Again, we're ignoring air resistance in this problem. And so what we're trying to find is when it reaches the ground, so when the final height is 0 meters, what was the velocity of the house and how much time did it take? So to find the velocity of the house, there's a few different ways we could do this. One would be to answer part B first, to find the time that it takes to reach the ground, and then go back and figure out what velocity it had at that time. But we can also do the problem in the order that's presented. We can find the velocity first. To find the velocity without having the time, we have to use the equation that relates the velocity to the position. So we have the equation that the final velocity squared equals the initial velocity squared plus 2 times the acceleration times the final position minus the initial position. Again, in this, because we're looking at something moving vertically, I'm using y for the position instead of x. So with this, we have that the final velocity squared is going to equal the initial velocity 0 squared plus 2 times the acceleration of negative 9.8 meters per second squared times the final height of 0 minus the initial height of 3,000. Again, in this problem, based on saying that the initial height was positive 3,000 meters and the final height was 0 meters, we're calling up the positive direction. So this is going to be something that we're going to have to keep in mind. The house is going to be moving downward, so we're going to need to make sure that our answer is negative. So with this, I have that the final velocity squared is 2 times negative 9.8 times negative 3,000. So the velocity squared is 58,800. So I take the square root of that, and this is where I have to be careful. So the velocity is the square root of 58,800, which if you do it on your calculator, you're going to get 242.48. But you have to be careful because this house is moving downward. You have to remember that the square root of something is plus or minus. And so the square root of 58,800 is plus or minus 242.48. So this means that this final velocity is negative 242.487 meters per second, or 242.487 meters per second downward. Because velocity is a vector, you need to include information about what direction it's traveling. So you either have to do that by, since we said that up was the positive y direction, then we need to make our answer negative to represent the negative y direction, or we need to say specifically that it is moving downward. To find how much time it took to reach the ground, we could use that velocity that we found, figure out how much time it takes to go from 0 to 242.487 meters per second downward, or we could relate the height and the time. And so that's what I'm going to do. That's the more common way that people would think about it. So if we look at the equation relating position and time, we have that the height equals the initial position plus the initial velocity times the time plus 1/2 the acceleration times the time squared. So doing this, the final height is 0. It equals the initial height of 3,000 meters plus the initial velocity of 0 meters per second times t plus 1/2 times negative 9.8 meters per second squared times t squared. Again, 0 times t is still 0. 0 times anything is 0. And so we have 0 equals 3,000 plus negative 4.9 times t squared. So I'm leaving off the units for this just for simplicity. And so to solve this for t, we have to take the 4.9 t squared over to the other side. So 4.9 t squared equals 3,000. So t squared is 3,000 over 4.9. And so then we have to take the square root of both sides. So we're going to get a time of the square root of 3,000 divided by 4.9. Which gives us a time of 24.744 seconds. Again, you might say, well, that seems like an awfully long time. Well, that does seem right. That did fall from 3,000 meters. If we look at 9.8 meters per second squared, it should take about 24 seconds to reach a velocity of over 200 meters per second. So again, the answers do seem to agree. Again, this is why this problem, it's not perfect to ignore air resistance, because something that's moving that fast and that's been falling for that long is going to have air resistance. That's going to be a little bit more important. But again, in this chapter, we're neglecting air resistance. In this next problem, we have a ball dropped from the top of a building, and it takes 3.5 seconds for the ball to reach the ground. And we want to figure out what the velocity of the ball was as it reached the ground and how tall the building was. So we don't know this height of the building. So it's starting from some unknown height. We know that this final height is going to be 0. So setting things up, my initial height, I don't know. My final height, I do know, is going to be 0 meters. My initial velocity for this is going to be 0 meters per second because it's being dropped from rest. I'm not sure what my velocity is right before it reaches the ground. Again, it's free fall, so I know that the acceleration is negative 9.8 meters per second squared. And I know that it reaches the ground after 3.5 seconds. So again, with this, I'm trying to find what is the velocity at this time, and I'm trying to figure out what height did it fall from if it has a position of 0 at that time. So to find the velocity as it reaches the ground, I want velocity as a function of time. So that's the equation v equals v0 plus the acceleration times the time. And so I have that the final velocity is going to equal the initial velocity of 0 plus negative 9.8 meters per second squared times 3.5 seconds. And so this gives me a velocity of negative 34.3 meters per second. Can we see that if we're using the equation for velocity as a function of time, if our velocity should be downward, it does work out to be negative right in the problem, unlike the last example where we had to remember that to make the answer negative. With this equation, anytime it's supposed to be negative, it will come out in the answer. And for the second part to this question, how tall is the building, we're going to relate the position and the time. So we look at the final height y was the initial height y0 plus the initial velocity times the time plus 1/2 times the acceleration times the time squared. So in this we knew that the final height was 0. We're looking for the initial height. The initial velocity was 0 meters per second times the time of 3.5 seconds plus 1/2 times negative 9.8 meters per second squared times the time of 3.5 seconds. It's that quantity squared. So I have 0 equals the initial height y0. 0 times 3.5 is just 0. And then we have 1/2 times negative 9.8, so we have negative 4.9 times 3.5 squared. So this is going to give us negative 60.025 meters. So I solve for the height, and I get that the initial height was 60.025 meters. So if it took 3.5 seconds to reach the ground, that means that it had to have been falling from a height of 60 meters, a little over 60 meters. For the spinal problem, we have a ball thrown upwards from the ground. And so this ball is thrown upwards at 40 meters per second. So it's going to go upwards, it's going to go up, and it's going to come back down, and it will eventually reach the ground again. And so this ball is starting at a height of 0 meters. The initial velocity of this ball, we're going to make up the positive direction. That makes the initial velocity of this ball positive 40 meters per second. The acceleration of this ball on the way up and at the highest point and on the way down, the entire time it's in the air from after it leaves the person's hand until right before it reaches the ground, it has an acceleration of negative 9.8 meters per second squared. Again, this is important. Even when the ball is on the way up, the acceleration is downward. Gravity is pulling downward on the object. Again, on the way up, the velocity is positive, the acceleration is negative. The velocity is upward, the acceleration is downward. That's what causes the ball to slow down on the way up. At the highest point, even where the velocity is 0, it is still accelerating. There is an acceleration because it's changing directions at that point. And on the way down, it is still accelerating downward, and so now the velocity is downward and the acceleration is downward. When velocity and acceleration are in the same direction, the object speeds up. So because the acceleration is negative 9.8 meters per second squared the entire time, again, this is still just a constant acceleration problem. It's still just the same as any of the other free fall problems. And so this problem, this first part, is asking what is the height of the object, how high is the ball, when t equals 3 seconds. So again, we're going to look at the height as a function of time. So we have the height y equals the initial height, y is 0, plus the initial velocity times the time, plus 1/2 times the acceleration times the time squared. So looking at the values, the final height y equals the initial height of 0, plus the initial velocity of 40 meters per second times 3 seconds, plus 1/2 times negative 9.8 meters per second squared times 3 seconds, that quantity squared. So the height is 0 plus 40 times 3 is 120 meters, plus 1/2 times negative 9.8 times 3 squared is negative 44.1 meters. And so this height at 3 seconds is 120 plus negative 44.1, which is 75.9 meters. So again, you can find the height of the object at any time using the equation relating position as a function of time. Finding the velocity of the ball at 2 seconds. Again, we're going to use the equation that relates velocity and time. So the velocity will equal the initial velocity plus the acceleration times the time. And so we have that the velocity at 2 seconds will equal the initial velocity of positive 40 meters per second plus negative 9.8 meters per second squared times 2 seconds. So we have 40 plus negative 9.8 times 2 That gives us a velocity of positive 20.4 meters per second. The fact that the velocity is positive means that it's still on the way up. 2 seconds is less than the time to reach the highest point. So again, as it goes upwards, the velocity is going to become less positive and less positive and less positive. At the highest point, the velocity is going to be 0, and then the velocity will become negative as it starts falling back downward. How long will it take for this ball to reach the highest point? So again, it's still the same ball thrown upwards at 40 meters per second, and it's going to go up. At this highest point, the most important thing to know is that when it reaches the highest point, the velocity is 0. You have to understand that it stops going up before it can start coming back down. And so at that maximum height, the velocity is 0. And so again, the initial height is 0 meters. The initial velocity is positive 40 meters per second. The acceleration is negative 9.8 meters per second squared. And part C is asking at what time is it at the highest point. So it's saying at what time is the velocity equal to 0. So one of the strategies for this is to understand how you can rephrase the question. You have to understand that the highest point, they're always referring to the point where the velocity is 0. And so you're going to be looking for what is the height when the velocity is 0, or what is the time when the velocity is 0. So this one we want to know at what time is the velocity equal to 0. So we're going to use the equation that we used in the previous part. The velocity equals the initial velocity plus the acceleration times the time. Doing that, we have that the final velocity of 0 equals the initial velocity of 40 meters per second plus negative 9.8 meters per second squared times t. And so if we solve this for the time is 40 divided by 9.8, which is going to be 4.0816 seconds. So it reaches the highest point at a time of 4.0816 seconds. Again, let's check to see if this makes sense. In part B, we were looking for the velocity at 2 seconds. We found that the velocity at 2 seconds was positive. It was still on the way up. That agrees with what we have in part C. We said that it was going to take 4 seconds to reach the highest point, 4.08 seconds. And so at 2 seconds, it should still be on the way up. That also means that in part A, when we calculated the height at 3 seconds, it was still on the way up. With that, there's not really a way to tell that other than by looking at the velocity at 3 seconds or by looking at what time it reached the highest point. But again, this was something where at 3 seconds, it was, part way up, but it was still on the way upward. Part D, how high will the ball be when it reaches its highest point? So one way to do that would be to find what is the height at 4.08 seconds. That would be very similar to what we did in part A, where we plugged in the time and we found what was the height at a certain time. So that would definitely be one way of solving it. Just to do it slightly differently, the other way we could do it is to use the equation that relates the velocity and the position. So the final velocity squared equals the initial velocity squared plus 2 times the acceleration times the final height minus the initial height. So again, we're looking at the highest point, so the velocity at the highest point is 0. So we have 0 squared equals 40 squared plus 2 times negative 9.8 times the height at the highest point, y, which we're looking for, minus the initial height, 0. So we have 0 equals 40 squared is 1,600. So we have 0 equals 1,600. 2 times negative 9.8, that's negative 19.6 times y. And so when we solve for this height, It's 1,600 divided by 19.6, and we get 81.633 meters. Again, a few things to check. In the first part, when we found the height at 3 seconds, it was less than this, so that does make sense. It should be, if this is the highest point, any other time it should be at a height smaller than this. Um, Again, you could go through and try and solve it with the time that we found in part C, the same way we did part A, and you should get the exact same answer. Part E, what will be the total time that the ball is in the air? So again, with this, the ball is going up, it's coming back down, and so it's still starting at a height of 0 meters. The initial velocity is still positive 40 meters per second. The acceleration is still negative 9.8 meters per second squared. So you saw that no matter what part of the problem we were looking at, the initial height, the initial velocity, the acceleration, those all stayed exactly the same. But depending on what part we were looking at, the later height, the later velocity, and the time, those all change. So in this, we're trying to find the total time that the ball is in the air. So we're trying to figure out at what time is it back at a height of 0 meters. And so if we use the position time equation, we have y equals the initial height y0 plus the initial velocity times t plus 1/2 times the acceleration times t squared. Plugging in our values, we have that 0 equals 0 plus 40 meters per second times t plus 1/2 times negative 9.8 meters per second squared times t squared. Or 0 equals 40t minus 4.9 t squared. And so to solve this, because we have a 0 on one side of the equal sign, and everything on the right side of the equal sign has a t in it, I can factor out a t. So I have 0 equals the quantity t times 40 minus 4.9 t. Again, this only works if you have a 0 on one side of the equal sign, because 0 times anything is 0. If you don't have a 0 on the other side of the equal sign, you could definitely factor something, but you can't set those factors equal to anything because, you know, it's only 0 times anything that gives 0. So we're setting each of these factors equal to 0. So either t equals 0, which we should expect as one of our answers because it did start at the ground. And so when t equals 0, the height was 0. Or we have 40 minus 4.9t equals 0, which means that the time is going to be 40 divided by 4.9, which is 8.163 seconds. That's the total time that it's in the air. Again, if we compare this to the time to the highest point, we do see that the time to the highest point is half of the total time that it was in the air. And we should expect this. This is symmetric, and so going from the ground to the highest point, and then going from the highest point back to the ground, it should take the same time to go up and then to come back down. And so the total time the ball is in the air should be twice the time to the highest point. The important thing is not mixing up how to find the time to the highest point and the total time that it's in the air. Often a mistake that students will make is they'll calculate the time to the highest point thinking that that was the total time, and then they cut that in half for the time to the highest point. That would not be true. Or they'll find the total time that the ball is in the air, thinking that that's the time to the highest point, and they'll double that time for the total time that it's in the air. And that would be incorrect. You need to know which one is which. And it is okay to then understand the relationships between them, but make sure that the time that you were using is actually what you thought it was. Part F, what is the velocity right before hitting the ground? That means that we want to find the velocity at 8.163 seconds. Um, so if we do this, we have that the velocity equals the initial velocity plus the acceleration times the time. So the velocity is going to equal the initial velocity of positive 40 meters per second plus negative 9.8 meters per second squared times the time of 8.163 seconds. Now, if I use 8.163, if I use that rounded number, I'm going to get a number that's slightly different. On my calculator, I have the full answer of 40 divided by 4.9, which is 8.163265306. If I use that full number, I will use that full number as I'm doing this, just because I want to illustrate a point. If I do this, I have 40 minus 9.8 times that full 8.1632653. I'm using the answer, and I get that the velocity is negative 40 meters per second. If I used my rounded off number, if I did 40 minus 9.8 times just 8.163, I get negative 39.9974 meters per second, which again rounds to negative 40, but it doesn't become exactly as clear as this. When it reaches the ground again, when it reaches the height that it was thrown from, the velocity is exactly the same size. So the speed is the same, 40 meters per second. It's just moving in the opposite direction. Again, that comes from the fact that it's symmetric. If it went from 40 meters per second to 0 meters per second on the way up, it goes from 0 to negative 40 on the way back down. The velocity decreased by 40 on the way up. It decreases by another 40, going from 0 to negative 40 on the way back down. So everything is symmetric. Again, the other way to see that is if we looked at the equation that related velocity and position. This position here is 0. This position here is 0. 0 minus 0 is 0. So this whole term would go away, and we would get that v squared equaled 40 squared, which means that v squared is 1600. V is the square root of 1600, which is, again, you plug it in your calculator, you get 40. But again, you have to remember that the velocity is plus or minus 40. And so you need to know that that means that the velocity at the ground, because it's moving downward, is negative 40 meters per second. Again, these problems of throwing something up into the air are no different than the problems of something being dropped from a certain height. You still have the acceleration the entire time is negative 9.8 meters per second squared. You just have to go through and you do have an initial velocity, unlike the other problems where the initial velocity was 0. Again, it just takes practice. The more you do these problems, the easier it gets. And, you know, if you keep doing them over and over and over, eventually you'll know exactly what steps to do in all of the problems.